The video that I will be doing will be over related rates. Related rates. So what we're talking about in related rates is how to relate a formula to its change in according to time. So, for example, how is cost changing in according to time? How is profit changing in according to time? How is a volume of something that's expanding or shrinking? How is that changing in according to time? So, for example, what is the volume doing at exactly 5 seconds? Is it getting bigger? Is it expanding? Is it decreasing? What is the rate in its accordance to time? That is related rates. Now, the example that I will be providing is pretty simple, but hopefully gives a great background. Here's the example. Y is equal to x cubed, and we have to find dy dt. So find dy dt. So this implies that y and x are both functions in terms of t. So both y and x are changing in according to time. And we're going to do this if x is equal to 2 and dx dt is equal to 4 at t is equal to 1. So in order to do this problem, we're going to have to take an implicit derivative. We're going to take an implicit derivative with respect to t. Excuse me. Let's change that. So it'll be y is equal to d over dt x cubed. So we know on this side, the left-hand side, is going to become 1. And then on the right-hand side, it's going to be 3x squared dx dt. So now what we're going to do is going to plug in the numbers that we have and figure it out. We'll have dy dt is equal to 3 times 2, since x equals 2, squared times 4. So typically we would have units, units in time could be seconds, hours, years, totally depending on the circumstance. One important thing that I forgot to mention is that if you take a look at x and dx over dt, that they will change for certain times. So for example, if it said t was to equal 2, those x and dx over dt, those would change. But here in this example, what's happening at t equals 1, we have the information that x is equal to 2 and dx over dt is equal to 4. And we were able to simply substitute x for 2 and dx dt for 4 in this problem, just because we knew that. Also, what I wanted to mention was the dx dt is the rate of the change of x according to the time. So once again, we just were able to plug in and able to get our time as 48. And that is it for my related rates problem.